Hi, my name is Bethany Friesenhahn, and I'm a graduate student at Texas A&M University, Kingsville. And I'm going to talk to you about movement and resource selection of wild pigs in relation to crop growth stages. Just some background of wild pigs. They were first introduced to North America in the 1500s as a source of food for settlers. Over time, they were released or escaped from homesteads, which over time led to the development of a wild pig population. They're omnivorous, so they eat both plant and animal materials, which makes it easier for them to survive in different environments. They have high reproductive rates, so they can have up to 2 litters per year, and those litters can range from 4 to 12 piglets per litter. The most important thing you need to remember about pigs is that they're very destructive and invasive animals that are currently there's currently a big effort going on to study and control them. Wild pig populations have been expanding rapidly because 1, they're good at surviving, and 2, they're a desired trophy and recreational hunting species. In 2004, the population was estimated at 4 million pigs. And then coming to today, there are around 6.9 million pigs, with 2.6 million of those being in Texas alone. If you look at the map, they have taken over California, Texas, and the southeastern states of the US. There are sporadic populations in the northern states, and that is most likely due to humans transporting them or releasing them for hunting purposes. With population expansion comes more damage. Wild pigs tend to target agricultural resources as part of their diet base on what is available. There's an estimated of $1.5 billion in damage per year in the US. If you look at the map I have on the left, it is a USDA map of corn planted per county. The map on the right is feral swine populations per county in 2018. The bulk of the corn is grown in the US and is still pig-free, but all of the counties with corn production in Texas, Louisiana, Mississippi, Alabama, and Arkansas have pigs, so this can be challenging for producers. From interactions with landowners, farmers, ranchers, and wildlife services and previous studies, we know that pigs depredate crops, but what we need to better understand is the spatial and temporal extent of the damage that is occurring. Understanding how wild pigs move throughout the landscape and when they select for crops will help us learn just that. Once we know when a crop is most vulnerable, we need to protect those resources by carrying out different control methods. There are both lethal and non-lethal methods to use on wild pigs. There's a cost benefit and a time of the year that is most effective for each of the methods as well. Take, for example, aerial hunting. You can remove a lot of pigs in a short period of time, but it is not as effective in times of the year that have a lot of vegetation growth or in areas that have tall trees. So it can be beneficial, but it really depends on the area you're in. Trapping is a great method, but it can be very time consuming. So knowing when wild pigs are moving towards crops will be beneficial for time management and effectiveness. Non-lethal methods include mostly fencing, which can be a year-round solution, but the cost up front can be expensive. So knowing the cost-benefit trade-off of protecting crops and preventing yield loss over time may be worth it. So my overall goal and objectives are to monitor spatial use and responses of wild pigs and quantify resource selection during different corn growth stages. My study area is in Delta County, which is in northeast Texas. This landscape is very fragmented with ag fields and pastures, and there's riparian areas and wooded areas that act as corridors for wildlife. We trapped and collared in January and February of 2019 and 2020. We had a total of 68 collared pigs that we chemically immobilized. Those GPS collars were gathering data at hourly locations, and they were programmed to stay on the pig from throughout the whole growing season and fall off around September 1st after corn was harvested in our area. To determine resource selection, I downloaded the Cropscape cropland data layer for both 2019 and 2020 and reclassified the image to only show the 4 classes I was interested in for my analyses. These 4 cover types include corn, which is our focus crop for the study, other crops, shelter, which includes wooded areas, riparian areas, and then pasture. For my analyses, I wanted to look at distance instead of categorical, so I use the Euclidean distance tool to create distance rasters. We already knew that pigs depredate corn, but we wanted to dive a little deeper and look into the different stages of corn and how pigs select those differently. So we split it up into 5 corn growth stages based on the information we gathered from farmers, such as planting dates and harvest dates. So the pre-planting was a 30-day period, and that's just kind of the baseline. There's no corn in the ground yet, just kind of creating those home ranges and resource selection for those pigs. The establishment stage, which includes the seed being placed in the ground, germination, and emergence. Vegetative stage, so the plant is just forming leaves. It's right after emergence and right before the plant goes into reproductive stages. The blister milk stage, so the plant is forming those kernels, but they're very small and they're soft, have a milky liquid in it. And the dent mature stage, which has the kernels drying out. They have a dent kind of in the kernels if you look at them, and then all the way up until the kernel is ready to be harvested. So jumping into methods, for movement responses, I looked at home range centroid distance to crop per growth stage to determine if pigs move their home ranges closer to corn. I created home ranges for each individual pig using a 95% movement-based kernel density estimate. From there, I calculated the home range centroid and arc map. A distance raster from cornfields was used to extract values to each centroid. Methods for resource selection. So I ran step selection functions using the AMT package in R. Step selection functions calculate step length and turn angles between the individual's consecutive GPS locations or use locations. I then created 10 random steps based on the step lengths and turn angles to each use step to determine what was available to the pig. So if you look at the illustration on the right, it kind of shows the red lines are the actual steps that the pig took, and then the dotted black arrows are the steps that the pig could have taken, so the available location. That's where that use versus available comes into the analyses. Once I had those, the use step and the 10 random steps, I extracted the land cover type covariates to each step and generated a model to look at each growth stage and determine if there was an interaction between year and each cover type. The results for the movement responses and looking at mean centroid distance to corn. So in this graph, I have the growth stages on the x-axis and the distance in meters on the y-axis. I calculated the mean centroid distance to corn in males 2019, the females in 2019, males 2020, and females 2020. For the pre-planting stage, that just pre-planting stage, it just kind of explains where they were in relation to corn after their trapping events. Once the establishment stage begins, 2020 females show on average they were 225 meters closer to corn than their original home range centroid. The vegetative stage distance to corn increases in 2020 by 150 meters with no real change in 2019. But during the blister stage, pigs move closer to cornfields on average from 225 to 450 meters, with the 2019 females moving 50 meters further. And for the dent mature stage, the pigs were not closer to corn than the blister milk stage, but they did not move far and they still stayed closer than their previous stages. So after looking at that graph, you can kind of see that there was variation throughout the years and between the individuals on how they were moving their home range centroid. So I threw this map in here to kind of show, this is probably one of my most extreme pigs that travel towards crops. So if you look at the points on the map, this female was trapped in a wooded area where there wasn't much agriculture around. But if you look at the pink points, which is the blister milk stage, they move towards the cornfields and they hang out, and this pig hangs out there most of the dent mature stage until it makes its venture back 8 kilometers to its previous home range. So it was interesting to see that a pig would travel 8 kilometers away from its home range it had for months just because the corn was reaching that blistered milk stage and dent mature stage. So results for resource selection. I have similar graphs like this for the next 4 stages. So I'm gonna kind of explain it. I have the land cover type on the x-axis and the beta coefficient on the y-axis. If the bar is above the 0, then it's considered avoidance. If it's below the 0, it's considered selection or nearer than expected at random. I combined all pigs for both years and did not find a difference in years overall, but I will address that the strength of the effect varied by year for certain land cover types. So for example, in the pre-stage, they strongly selected for shelter, but they avoided other crops, and there was the strength and avoidance varied between years for this stage. The establishment stage, pigs strongly selected for shelter and avoided pastures, with the strength of avoidance again varying by year. Just from interacting with farmers and wildlife services and walking on the ground and monitoring our fields throughout the year, we did see pig damage occurring to fields, even though our establishment stage isn't really showing selection of pigs. So that would be interesting to kind of look deeper into. During the vegetative stage, there's strong selection for shelter again, and the plant at this stage doesn't really provide a nutritional value to the pig. So this kind of matched up to what we were thinking we were going to see. So it was weird though, as we were walking the field, we did see in this picture on the right, it looked like plant material was kind of chewed up and left, and there was pig tracks near it, as if the pig was almost testing the plant to see if it was ready. During the blister milk stage, there is a strong selection for both corn and shelter, which is the first phase that stage that we actually see where pigs are selecting that the stage is being selected for. The kernel is very soft and sweet and has that milky liquid in it, so it makes sense that it's attracting pigs. And as we walk fields, we did see quite a bit of damage occurring during this stage. And lastly, the dent mature stage, where corn was selected for, but it wasn't as strongly as the blister milk stage. And again, shelter kept the trend where it was strongly selected. So from looking at the home range centroids and SSFs, it shows that pigs are attracted to cornfields more so during the later reproductive stages. Planting damage does occur, but it may not be showing as selected for because there are so many other resources available at that time. And rooting up one kernel every 8 inches may not be enough calorie intake for the pig compared to pulling down a full plant and getting that full year of kernels. Shelter was strongly selected for across the board, which lines up with pig behaviors of seeking shelter. They can't regulate their own body temperature, so they need to stay out of the sun or find water, and hiding from hunting pressure. Management implications. Knowing pig movements and when the crop is most vulnerable should be the time for removal efforts. Some removal efforts may not be effective during those times, which makes it difficult. Fence exclusions would be a year-round solution to keep pigs out, but there is a cost trade-off of paying for a fence and what you are saving from the yield loss from pig damage. Another option would be, since pigs are always selecting for shelter, it could be helpful to remove or thin heavily wooded areas or even avoid planting desired crops such as corn near those areas. Kind of move the kitchen away from the bedroom kind of situation. I hope that what we continue to learn from this study will be beneficial to producers and managers and help them in the battle against wild pigs. So with that, I would like to thank a ton of people, a bunch of faculty and students at CKWRI, the NWRC Fort Collins, Colorado crew, Texas Wildlife Services, and the private landowners and farmers in Delta County that so generously allowed us to trap pigs on their property. Thank you.